All right, so this first section is from the very first week, right? If you have your notes available, then you should have this. It talks about everything that you need to know to define a rational or irrational number. You can also just use your calculator for this, right? So writing a decimal, you just enter it into the calculator. 2 divided by pi, put it in as 2 over pi. That's going to be 0.6366, and it continues on. Nobody should have missed that. 15 halves, 7.5. Square root of 110, you press second x squared, enter in 110, and it's second x squared 110. It gives you a square root back, so if you see the decimal, you press that double arrow key, and it's going to be 10.488, and it continues on. To show it continues, just put the 3 dots. And then the square root of 16, second x squared 16. That's going to give you a whole number of 4. That is a decimal. You just put a 0.0 at the end. I get a lot of questions about that. Now, identifying whether it's rational or irrational. Rational numbers are either terminating or repeating decimals. Okay? If it does not terminate and does not repeat, then it's going to be irrational. So this one, irrational. This one terminates, it's rational. This one keeps going, irrational. This one terminates, rational. That's what you should have. All right, now this is still continuing with that same lesson, except for now it's just converting. So take your fraction, and you have your calculator available, so you can just type in 2/3. We see that it is a repeating decimal of 0.6. So 0.6, and make sure you use bar notation over that to show it repeats. In our calculator, it does have a 7, okay? But like I've said several times, it rounds that very last digit. Going the other direction, how to take 0.2 repeating and turning it into a fraction. You literally type in 0.2 and go all the way to the edge repeating, then press your double arrow key, because it fractions to decimals, decimals to fractions, and press enter. It gives you 2/9. So that is the fraction you should have there. 23/9, just type it in, 23 over 9. 2.5 repeating. Make sure you're using bar notation over that 5. And finally, this 0.2 with just the 5 repeating. So 0.2 with just a 5 repeating. 23 over 90. All right, our next section are the notes over. That's what it is. This is 2 over 9. All right, so the next section is whenever we talked about roots and square roots and cube roots. So we are just going to be calculating that in our calculator also. That would be our irrational number. So they're telling us all of these are irrational numbers. We're just writing them as decimals. And then we're telling which number it's between. Very few people missed these sections. So the square root of 12, second x squared 12, 3.464. That's enough information. It's between the numbers 3 and 4. What's the largest number less than the decimal? 3. Okay, sometimes people like to tell me it's 2. That 2 is not the largest one, smaller than it though. 3/4 and then pi. So 2.356, and it keeps going. So that's between the numbers what? 2 and 3. What's the largest integer less? 2. Square root of 150. Our decimal is 12.247. It does continue on because it's irrational. That's between what two numbers? And what's the lowest? All right, and then cube root. A lot of us forget how to type in the cube root. You have to have the 3 first, second, and then your caret key for exponents, right? Notice that it pops up a little 3 here. And then you're going to put 130. That's 5.065. Continues on. Between what two numbers? And then 5. All right? So this is the only one that people normally miss. The rest of this is just typing in the calculator and identifying what two numbers it's between. All right, the most missed section or the most skipped over section is for our exponents. The exponent notes were these, okay? So for this first problem, k to the negative 8th power. If you find on your notes where it has a negative exponent, a to the negative n, that's the exponent one. And it even says negative exponents. Here's some examples. 5 to the negative 3rd is changed to a fraction by 1 over 5 to the 3rd. Here's another example. X to the negative 7th is 1 over x to the 7th. So we just need to rewrite it so that 1 is in the numerator and then put our power in the denominator, and then now it's positive. So this is 1 over k to the positive 8. Okay, for this next one underneath it, it's a power raised to a power, c to the 5th raised to the 6th. Okay, so on our notes, power of a power. What are they saying that we do with these exponents? Multiply them. So we are going to write c to the what?
30.
Okay, so those of you that are writing just a number 30, that's not right. It's not 30 simplified. It's c to the 30th. All right, now if we have a product of powers, meaning we're multiplying them, that can be found here on the notes. What do we do with the exponents? Add. So what is 3 and 15? 18. So write m to the 18th, right? All right, the next one, anything to a 0 exponent, we can find that on our notes. Anything to 0 is 1. It's not 0, guys. It is 1. Now, whenever we have a fraction here, that's division. That means we're finding a quotient of powers. Okay, so here it is here. What do we do with the exponents? Subtract. That simplifies it, and if you look further, we keep the base, and when we subtract the exponents, that's our new exponent. Okay? So 46 minus 3 is g to the 43. It's not 43, it's g to the 43rd power. When we have a power of a quotient, that's what this looks like. So you have an exponent on the outside of the whole entire fraction. Put the power on the numerator and on the denominator. So that's going to be a to the 4th over b to the 4th. All right, and finally, this last problem. You could simplify it using each one of these rules, or you have your calculator, set up your fraction, set up your parentheses. It's 6 to the 3rd times 6 to the 3rd. Close the parentheses, raise that entire thing to the 2nd. And in the denominator, 6 to the 7th times 6 to the 5th. And that's going to give you 1.